Hey boys and girls, welcome back to another edition of Crush Lusher Television. Okay, so we are going to do some Riemann sums. A lot of people asked for this review, and so this is good because it's the Riemann sum integral connection. No calculator allowed. So we have this chart right here. So T in hours and R of T in gallons per hours. The rate at which water leaks from a container is modeled by the twice differentiable function r, where r of t is measured in gallons per hour, and t is measured in hours for 0 is less than 1, 0 is less than t is less than 1, so anything between 0 and 1 hours. Values of r of t are given in the table. Okay, so at 0 hours, at a third of an hour, at 2/3 of an hour, at 1 of an hour, this is how many gallons per hour are leaking. So this is a rate right here. So even though it's not a prime, I know that this is a rate. So I'm going to do A, B, and C here. For D with the sum, ignore that right now. We're going to do A, B, and C, okay? So do your best to do A, B, and C. Try on your own. Ready, set, go! All right, let's check it out. So let's do easy. Try it out. Okay, so here's my recreation of the chart right here. So first, I'm actually going to do this. So I know that R of T, it tells me, is gallons per hour. So I mean that R prime of T is gallons per hour squared, which is the rate of the rate. Usually double prime, but it's not. And I guess this is like big ass R T, bigger R than this, more capital, and that's just going to be gallons if I need that. But it looks like I'm going to be sitting in this world right here. But let's see what happens. So A, I need to approximate R prime of 1/2. So what is that going to be? So 1/2 is between what? Oh, it's between 1/3 and 2/3. So I'm just like visualizing it. 1/3 is like this, right? And then that's less than a half. This is a half right here. And then 2/3 would be more than a half. So 1/2 sits right here. So it means these 2 points are what I'm going to use in my charty chart. So I'm just finding the slope. So I got T and R of T. So I got 1/3 and 8, and I got 2/3 and 5. So the change in R of T is -3. The change here, go from 1/3 to 2/3, that's 1/3, because 1/3 plus 1/3 is 2/3. Yeah, I can just ignore the denominators in this case. So like, how do I go from 1 to 2 on the numerator? Yeah, just 1. That's how I think about it. So your slope, so R prime of T, is change in y over change in x, which is when you divide by a fraction, you multiply by its reciprocal, so that's -9. But it also says you need the units. So R prime, so this is 1/2. So R prime of 1/2 equals -9, and we're R prime. Good thing I wrote this down. So I wrote this down. So the rate of the rate is gallons per hour squared. They're leaking out. There you go. Okay, B. Use a left Riemann sum with 3 subintervals. That's what it said. Okay, so left Riemann sum with 3 subintervals. So I have to write the integral first, because that's essentially what we're doing. We're finding the area under the curve. So I'm writing approximately. This is not exactly how many gallons have leaked out. So we're going to do left. So this distance right here is 1/3. And I can obviously draw a picture if I need to, but some people are really good, so I'm gonna go from the left. So that distance is 1/3, and this is the height on the left. So height is 11 plus 1/3, because 1/3 to 2/3, that's another 1/3. That's the distance of the base times the height, which is 8, plus 2/3 to 1 whole. That'd be 3/3. So 2/3 to 3/3 is another 1/3. And the height is 5. Bam. And so I can factor out of 1/3 here if I want. It's 11 plus 8 plus 5. Because like when you distribute, you get the same thing, right? 11 plus 8 is 19. 19 plus 5 is 24. So 1/3 of 24 is 8. units. So this is actually the integral of r of t. So the integral of r of t is big ass r of t. So the integral of this, we just found the area under this curve is going to be gallons. So it's approximately 8 gallons. That's what we got. However, you could have left the answer like this, and this would have been cool, because if you just have simplification left, that is cool. So if you say this many gallons, you write 2. Nice. Part C. All right, part C. So I got to find the integral between 0 and 1/3 of r prime of t dt. Okay, so r prime of t, you're finding the integral of r prime. This integral of r prime is just r. And this is r here. So this is just a chart problem. So the integral of r prime is just regular r. So that means fundamental theorem of calculus, this is r of 1/3 minus r of 0. The antiderivative of the integrand, and then plug in the top upper limit minus the antiderivative of the integrand and plug in the bottom limit. And this I just go over here to the chart. So r of 1/3 is 8. R of 1/3 is 8. And r of 0 is 11. So this is just 8 minus 11. Damn, that's hard. Seems pretty complicated, but it's not. -3, and this is going to be gallons per hour. There you go. Cool. That's A, B, and C. If you have any confusion with this, try it again. Good work. Excellent job, everybody. Take care.